Hi children, this is your Suvarna teacher. Children, in this video, we are going to learn about echo, reverberation and multiple reflections of sounds. What is an echo? If we shout or clap standing at a suitable distance from a reflecting object such as a tall building or a mountain, we will hear the same sound again a little later. This sound which we hear is called an echo. The sensation of the sound persists in our brain for about 0.1 second. This is called the persistence of sound. To hear the distinct echo, the time interval between the original sound and the reflected sound must be at least 0.1 seconds. This means that if a sound produced by a source is reflected in less than 0.1 seconds, the echo will not be heard. For sound to reflect after 0.1 second, what should be the minimum distance between the source and the object? Let us now derive a formula for finding our speed of sound to hear an echo. Let the distance traveled by the sound from the source to abstract is equal to d. Then the distance traveled by the sound from the abstract to sound is also d. Thus, the total distance traveled by the sound wave is 2d. Let echo time will be t seconds, then the speed is equal to total distance traveled by echo time, that is equal to 2d by t. And now we are going to learn about reverberation. A reverberation is perceived when the reflected sound wave reaches your ear in less than 0.1 seconds after the original sound wave. Since the original sound and reflected sound waves tend to combine to get to hear one prolonged sound wave. In an auditorium or a big hall, excessive reverberation is highly undesirable. To reduce reverberation, the roof and the walls of the auditoriums are generally covered with sound absorbent materials like compressed fiberboard, rough plaster, or straw materials. The seat materials are also selected on the basis of their sound absorbing properties. Children, if you conduct a small activity, it will be very fun. In a closed box, if you say hello, the sound here will be hello, like prolonged sound. You can hear the reverberation sound. The relation between echo and the reverberation is reverberation is quite different from an echo. A reflected sound arriving at the position of listener more than 0.1 seconds after the direct sound is called an echo. A reflection of sound arriving at the listener in less than 0.1 second after the direct sound is called reverberation. Children, please enjoy and watch this video. You can have more idea about echo, reverberation and uses of multiple reflections of sound in our day-to-day life.
Sound, Part 4. Reflection of sound, echo and reverberation. In the previous video, we learned about speed of sound. In this video, we will learn about reflection of sound, echo and reverberation. Reflection of sound in solid or liquid mediums is like a rubber ball which bounces off when hit on a hard surface. Reflection of sound is similar to the reflection of light. When a sound gets reflected at a solid or liquid surface, it follows the same rules of reflection which are followed by light. The directions in which the sound is incident and the sound is reflected make equal angles with the normal of the reflecting surface at the point of incidence, and all three of them lie in the same plane. An obstacle of a large size, which may be smooth or rough, is required for the reflection of sound waves. Now, let us perform a simple experiment to understand the relationship between the angle of incidence and the angle of reflection. Take two identical pipes of sufficient length as such. Place them on a table near to a wall as shown in this image. Now place a clock or a vibrating mobile phone at one open end of one of the pipes. Then try to hear the ticking of the clock or vibration of the phone by placing your ear in the open end of the other pipe. To hear a clear sound of the ticking clock, adjust the position of the pipes as required. Now measure the angle of incidence and the angle of reflection of the sound and establish the relationship between them. Change the position of the pipe on the right by lifting it vertically and observe what happens. Now let us learn how reflection of sound produces echo. When you clap your hands near a reflecting surface like a mountain, you will get to hear the same sound a little later. This sound which we hear is called an echo. Why do you think echo occurs? Echo takes place as the sound is reflected back after hitting a reflecting surface. The sensation of sound persists in our brain for about 0.1 seconds. To hear a distinct echo, the time interval between the original sound and the reflected sound must be at least 0.1 seconds. Now, suppose the speed of sound in air at 22 degrees Celsius is 344 meters per second. The sound must hit the obstacle and reach to the ear of the listener after 0.1 seconds. So, the distance travelled by the sound from its source to the reflecting surface and back to the listener should be at least 344 meters per second multiplied by 0.1 second, which is 34.4 meters. So, to receive a distinct echo, the minimum distance between the source of sound to that of the reflected surface should be at least half of this distance, that is 17.2 meters. This distance will vary with the temperature of air. You can also hear echoes more than once when there are multiple or successive reflections. Due to this reason, rolling of thunder sound also occurs. The thundering sound undergoes successive reflections from multiple reflecting surfaces like the clouds and the land. Now, let us learn about reverberation. When we create a sound in a big auditorium, it persists for some time due to repeated reflections from the walls, until it is reduced to a value where it is no longer audible. This repeated reflections that lead to the persistence of sound is called reverberation. In an auditorium or big halls, excessive reverberation is highly undesirable. Therefore, to reduce it, the roofs are mostly covered with sound-absorbent material like compressed fiberboard, draperies, or rough plaster. Even the material of the seats are chosen on the basis of their sound-absorbing properties. Now, let us solve a simple problem together. Suppose you clapped your hands near a cliff and you heard the sound after 3 seconds. Calculate the distance travelled by the sound when the speed of sound v is taken as 320 meters per second. Here, speed of sound v is equal to 320 meters per second. Time taken for the echo to reach your ear is equal to 3 seconds. We know distance travelled by the sound is equal to v multiplied by t, which is equal to 320 multiplied by 3, which is equal to 960 meter. Now, what do you think is the distance between you and the cliff? We learned about multiple reflections. Now, let us see they are helpful in what ways. Megaphones, horns, and musical instruments such as trumpets use multiple reflections. They are designed to send sound in a particular direction without spreading it in all directions. These instruments have a tube followed by a conical opening, which reflects sound successively. It guides the sound waves from the source in the forward direction towards the audience. Stethoscope, which is used by doctors to listen to the sounds of the heart and the lungs in the human body, is another example of multiple reflection. Here, the sound reaches the doctor's ear after going through multiple reflections. In this video, we learned about reflection of sound, echo, and reverberation. In the next video, we will learn about sonar and ultrasound.
So children, I think you have a clear idea about echo, reverberation and uses of multiple reflections of sound in our day-to-day life. Thank you children.